Hi there, this is Curriculum Hotspot for LS23. This is part of the Ecosystems Interaction, Energy, and Dynamics. Okay, we'll first see this standard in Lesson 2.2, where we cover aerobic and anaerobic respiration. This standard actually has a little bit more into it because it's supposed to cover some of the loss of energy through cellular processes such as respiration and that movement of energy through ecosystems. So I think it would be good to mention that, but keep in mind we're going to cover that later. So these two units can be linked and access prior knowledge when we get to it later on. As always, remember to look ahead, make sure you have all your materials. It says this lab needs clothespins. I will give you an option that doesn't require clothespins, but you do need the other materials if you want to complete the labs for this unit. Again, in lesson 2.2, we're going to focus on aerobic and anaerobic, continuing to build on what we just taught them about cellular respiration. As we continue to work with students with the idea of anaerobic processes of respiration, gaining energy even in low oxygen conditions, students may struggle with this. Also, they may struggle with energy lost and why isn't everything that I'm eating still in me, and that's because it's broken down and that energy is released through heat and cellular processes. So even though this picture may be included somewhere, it might be in a reading, it might be a model that they're using for something, they don't need to memorize this. So make sure that they know that if they're looking at this, they're looking at the conceptual understanding of getting that energy out of glucose. We're not looking at memorizing any of this. The phenomena for this unit is to choose a professional athlete and discuss how can that athlete generate energy when they're running out of oxygen. They can't breathe fast enough, their circulation can't go fast enough in order to supply their cells with enough oxygen for a major event. However, they still are able to perform. And then another question you can ask is, what if you were in Denver, Colorado compared to Annapolis, Maryland? They should be able to deduce that Denver, Colorado, being the mile-high city, would have less oxygen and therefore be a greater challenge to most athletes. This quick lab is a great opportunity to review safety, scientific procedure, variables, controls, experiment. With this lab, you prepare a bromothymol blue solution and students use a straw to blow into it. And they're going to do that at rest to create sort of a baseline production of CO2. They'll time that and see how long it takes. One of the big errors that I found with this lab is as students do their exercises, they're breathing faster. And so we're not really wanting to breathe faster. We're trying to measure that amount of CO2. So if they were to hum through their straw and make sure that that is the same rate, that will also reinforce the idea of keeping all your variables constant. This is a fairly quick reading that can be done in groups or individuals. The focus question is how long you hold your breath. I would definitely advise your students not to try and pass out by holding their breath. There are 5 questions that are actually really good questions at the end of this reading. This lab is linked within the curriculum, and it's a great opportunity for students to collect data, do some real-world science, and they get to experience what anaerobic respiration feels like in their bodies. And if you don't have the clothespins, you can also have students open and close their hands forcefully, and that will also initiate anaerobic respiration. They actually may even cramp up, their forearm may lock up, which further emphasizes the need for ATP and muscle movement. As mentioned in the beginning of the video, we're focusing on aerobic and anaerobic respiration for this lesson. However, part of this is also the idea that the energy decreases as it moves upward through the ecosystem into different trophic levels. We're going to be discussing it later on in another lesson, so it'll be a good opportunity to spiral this back in at that time. Thank you, and if you have any questions, please contact the AACPS Science Office.